graph the polynomial function, we have the function x power 3 minus 4x. So first step, we find the x-intercept. Finding the x-intercept, we just let the y equal 0. And we rewrite the function into the factor form. Because from the factor form, we can find the multiplicity information. And odd multiplicity, for example, your factor form has x minus a times x minus b equals 0. So the multiplicity of this example would be just 1. Look, we are looking for the powers on the top of outside the parenthesis of your factor form. So in that case, this would be an odd multiplicity. That means the graph will passes through x equal a and x equal b. It will just passing to that point. When the multiplicity form, you have an even number on the top. So this now even number will indicate the graph will touches x equal a, either above or below. So finding the x-intercept, rewrite it into the factor form so that you will see, you will find the information of the multiplicity. X power 3 minus 4x, we set equals 0. Take out the x, we'll have the x squared minus 4. Now rewrite them into a factor form. So you have the x times x, right? That's the only way you can get the x squared. The last term is 4. This is a product of two numbers. We know 2 multiplied by 2, you'll get a 4. The middle term is missing. That means there's no x term. That means minus 2 plus 2. That's the only way we can get a 0. So the factor form of the x squared minus 4 is x minus 2 times x plus 2. So that equals 0. Here, we can see the multiplicity here. Each of the term has just one power 1 on the top, right? This is x power 1, x power 1, x power 1. That means they all have an odd multiplicity. When x equals 0, x equals 2, and x equals negative 2. They all have an odd multiplicity. So that means the graph will cut through these 3 points on the x-axis. And now we can start to label those points. X equals 0, that means 0, 0. X equals 2, that means the point is at 2, 0. And the negative 2, 0. So the older pair will be 0, 0, 2, 0, and the negative 2, 0. The next step, we need to use the end behavior to determine the tendency of the graph. Now, finding the end behavior of the function, we just look at the highest degree power term and the leading coefficient number of the highest degree power term. Power 3 indicate is an odd function. Leading coefficient number, there's no number here. It's a positive sign. So we can determine the function characteristic of this one is an odd positive function. When you have an odd positive function, the end behavior, it will tend to like this direction. Rise on the right, fall on the left. When you have a positive odd function. So I'm going to give that direction of the graph, kind of like the end behavior that will tend to like this. This highest degree power term, highest degree power 3 also give us the information, the turning point. So the turning point is equal n minus 1, which is 3 minus 1 is equal to 2. So we will have the two turning points on the graph. That means you will have the parabola. One is facing down, the other one is facing up. Between this point here and here, I need to kind of like get more information of the y-axis. So we can, instead of using the symmetric, I like to just pick a point and substitute into the function to see what is the y value. For example, f of 1. I substitute point x equal 1 into the function. It gives us is negative 3. So x equal negative 1, substitute back to the function, it gives us is 1, the y is at 3. So that means they respect to the origin between this interval. Alright, now we have all the information. We can combine all the dots to sketch the graph. Keep in mind, your polynomial function must be a smooth curve. There is no gap, there is no sharp corner. Throughout the entire graph, there must be smooth curve. So I'm going to combine these three dots here, passing through 0, 0, and come here, passing through. Alright, the end behavior will tend to like this.